made a few bold statements in my appeal for YouTube last week, which I guess was it was risky to say we're going to make antennas and then not have a plan in place, but obviously there was actually a plan in place for me to do some antenna improvements. Now, to be honest, I'm here in the lab, and last time that I did my test I had a few antennas shown. I had my Beast shown as well, which obviously did really well. I expect the Beast, which is an 18 dBi Yagi, to do but really well in a link from where I am through to the back, which I will show a bit later, to the outside of the building. But when I look at the dipole itself, I obviously got what I got, which was okay. It's better than a laptop, so that is good. What I kind of, I'd almost say I put a brave face on the first video to show the marginal improvement I had when I put the basic antenna on from this one from Alpha. Was I didn't really see what I wanted to see as far as the improvement through the buildings and everything was supposed to be, and it got me thinking, and this is where I really want to get RF Shop and Blackout Technology to have their own idea on how to do these things, is to find a solution that works well. So this is my first I'd say MK1 of the antennas that we want to do, that I really want to propose for this kind of situation. MK1, it's a circular polarized antenna. At the end, first going to do experiments, and then at the end I will explain why I think circular polarized for me would work better, assuming that it's going to work well. If it's not, then obviously egg on my face, but the idea is that I first demonstrate this antenna as it is, and then after that I will explain why I'm going to do what I do, and then just present the roadmap of the antennas that RF Shop and Blackout Technology will produce as our own solution. First one is, this is as it is. It's basically going to be a fairly bare bone antenna. The idea is this is just a desktop solution. So this is indoors. Outdoors, what we'll do is we'll just modify the shape a bit so that it comes in these IP67 rated enclosures, so that you can put it outdoors and waterproof, because there is actually an O-ring and everything in there. So the antennas would be waterproof when they go outside. This by itself I call an indoor or desktop antenna. So you would put that on the table. You can put it anywhere you want and just have that point in the direction that you need. So similar to these types of antennas that you screw in and then you can swivel it into the position, this one would just be placed next to your device and then just have it stand in the direction that you want it to stand. Now let's test it on the actual VNA. It's just this is a test that I just do to see the actual return loss. That's the first test to see, is it actually matched? So does it accept all the energy you want it to accept in that particular band? If it does, I'm happy. And then there's also the I'd say the poor man's test for a radio engineer to see, is it actually radiating? So what you would do is you have this thing here, just put your hand in front of it and you see if there's actually stuff happening, and you can definitely see if an antenna is reactive or responsive. It does a lot as you have your hand in the way of where the antenna is supposed to radiate to. On the back, or places where you think this antenna is not supposed to do anything, you actually see there's not much happening. So I'm just going to change the camera to show the actual screen a bit better, and then I'll put this antenna on. I'll put the Omni on, just the standard Omni from Alpha, that one. Going to put that on so you could see the difference, that how less sensitive this thing is, but it's sensitive all around. And then I'll just put the Alpha on just to be fair, because this is not a bad antenna, it works well, but I think in multi-reflection environments, that's where the circular polarized is going to give us some benefit. So just going to move the screen and then let's see what we get. Go to return loss, so I'm just going to change to return loss. So it starts at 2 meg up to 3 gigahertz. So obviously this is a very wide band, way too much for what we want to use in this specific application. But it's what it's set up as, and it's always interesting to see. So first one would be, just going to take the actual Omni, connect that to the adapters. So you'll see, there you go, it is matched. So there's the antenna itself. I'm just moving it out of the screen. So there's the resonance, 2.4 gig. So I'll just put marker 2.4 gig. You see right there, it is resonant exactly where you want it to be. So the antenna itself, it's working well over there. Cool stuff. Now I think all I want to show you is I'm moving this close to it. You see it's working. So I'll just go all around the antenna in the screen. I'm not making this an absolute test. This is just for the sake of showing. So pretty close, like within 10 centimeters. This thing is really starting to bounce all over the place, as you can see. That's good enough for an Omni. You can see it's working, so that's cool. Now I'm replacing the antenna with the little Alpha, doing the same thing again. Okay, so the antenna is radiating towards the letters. So I have Alpha facing forward. You can see it's resonant, so I'm happy with the resonant frequency. It's looking okay. -10, it's reading -11, but of course I have a lot of stuff, so if I take it far away it gets a bit better. But just to show in demonstration again, if I go close, out of the screen, you see it does a lot. So it's quite reactive, so can't see that here, but about 20 centimeters away, it's starting to do a few things to the back. So if I turn the antenna around, so now Alpha is facing away, I do this, that's not much happening. So that tells me the antenna is radiating this way, not doing much this way. It's a good thing, so that's what you want. Cool. Now the big moment, I've seen this before, so I'm not going to be surprised at the result that I'm about to show you, but I can tell you I'm excited. This one. So there we go. Just want to introduce the baby properly. The text will be gone on the final prototypes. This is just a prototype. The antenna itself, it has a little foot piece, so that'll be the way it stands on the ground, and you can point it anyway. Screw it in, and there we go. It's matched. It's quite nicely matched. It's -13.2, so I'd be happy with that. Now I'm putting it here, the same thing. I'm just having my hand, it's still out of the screen, so trust me if I say it's 40 centimeters away, 30 centimeters away, and this is what's happening. I'll go a bit closer. You can see it's going all over the place, but even far away, it's really extremely sensitive to activities that I do on the antenna. So as a poor man's test, this antenna is just really sensitive. Very happy. That's not even a word for. I'm super stoked actually, because this is a good design. So I could see that I could potentially do a bit of tweaking on the antenna itself just to see if it's better in band. But really, if I look at this, why should I change this? It's just working pretty well. Now the flip side, if I were to take this facing this way, so the antenna is now facing away. If I do something here, as expected, I can get pretty close. There's not really much happening compared to the other side where I'm out of the screen, not much happening. So that's the antenna. That's really what I wanted to show as far as just basic RF principles is concerned. I accept the fact that many of you will not be antenna users, and not a lot of people get excited about antennas like I do. You probably want to see what does it do for your network. So rather than just showing you what I just showed here on the screen, I am going to quickly set up that test again where I have my R36 outside behind the wall, and I have a NHA in here, and I will just do a quick simulation or comparison between all the devices.